Welcome to the first tutorial where I will show you the basics of Shadron. Shadron is a procedural graphics editor where all elements are defined by user scripts, which consist of simple declarations and shaders written in GLSL, the OpenGL shading language. If you don't know GLSL, you may want to get familiar with its basics first. When you first launch Shadron, you can see a very simple user interface, and right now we can only click the Help button, which will open the offline documentation where you can find information about the syntax of the script. To get started, we first need to create our script. Create a blank text file and choose a name. You can also add .shadron as the extension, although it is not necessary. Now open the file in your favorite text editor. In this video I will be using Microsoft Visual Studio, but anything works, even plain Notepad. At the same time, open the file with Shadron or simply drag and drop it onto the Shadron window. Pressing the refresh button will reload the script, or if you right-click it, you can toggle auto refresh. When enabled, the script will be reloaded automatically every time it changes. Okay, now we will start with something simple. First we need to define a shader. A shader receives the position of the current pixel and must compute the color of that pixel. In Shadron, each shader is defined by a GLSL function. Our function will be called myShader. Its input parameter is a two-dimensional vector, the position, and it returns a vector with 4 components: the red, green, blue and alpha channel. For now, we will set the color to a constant value. Alpha will be set to 1, which is the maximum, so will red. Green will be set to a half, and blue to 0. This represents the color orange. Next, we must declare that an image called myImage should be created from myShader and specify its dimensions. Now when I save the file, we can immediately see the result. We now have an image which is filled with the orange color. To make something more interesting, we need to take position into account. The position is a value between 0, 0 in the bottom left corner and 1, 1 in the top right corner, regardless of the image's resolution. Let's compute the distance from the current pixel to the center of the image, which is 1/2, 1/2. We will use the distance function available in GLSL. If the distance is smaller than, say, 0.4, we will still return orange, but otherwise we will return all ones, which is the white color. As you can see, the result is a circle. It is not perfect. Its edges are a bit jagged, which can be fixed of course, but we have successfully created our first procedurally generated image. Now to save it, simply drag and drop the image into a folder and a PNG file will be created. In Shadron, you have complete control over the alpha channel. Therefore, if we change the alpha of the white color to 0, although it still looks the same in the window, when you save the file, you can see that it is transparent. You can also use constants. In this case, it might make the script easier to read if we declare our colors as constants. An important feature is the ability to define adjustable parameters, which allow you to fine-tune the output in real time. So for example, instead of just the number 0.4, we will define a parameter, size, which can be used to adjust the size of the circle. Now, as you can see, a slider for our parameter has appeared in the UI, and by moving it, the circle gets smaller or bigger. Finally, we will try to make a simple animation. An animated shader receives an additional parameter, the current time in seconds. We also need to change the declaration of image to animation, and we should also probably change its name to match. Of course, we need to use the time parameter. Let's set the current size of the circle to the base size plus the sine of the current time to achieve a kind of oscillating movement. Now we just use this current size in place of size and we're done. The circle is now animated. Since I call Shadron an image editor, let's see how it can be used to edit existing images. The first step is to declare an input image using the file initializer. Here we can specify the name of the file or just leave it empty and pick one later. That way we get a blank input image. An important feature of Shadron is that every image and animation is available as a texture to other shaders. This means that we can sample it with the glsl texture function using the image's name as the sampler. For now, let's just return the sampled color. Now we declare the output image as before. To make it the same size as the input image, we can use the sizeOf operator. Now we just load an input image, and as you can see, the output is identical. We can of course change the sampled color before returning it. For example, replacing the green channel with blue. Or to make the image black and white, we compute the average of the three color channels and copy that value to all of them. Another simple modification is gamma correction, where we simply exponentiate the output by the gamma value. Once you are satisfied with the result, you can of course save it the same way as before. Shadron also has a library of useful functions available for use in your scripts. There are various noise functions, coordinate transformations, 2D and 3D shapes, and more. They can be accessed through the include directive. You may also include your own files and build scripts in a modular fashion. For example, if you include the library file HSV, you can use the HSV function to get a color from hue, saturation, and value. A very useful function in procedural graphics creation is Berlin noise. It is also directly available in Shadron. This is how it looks. Another useful type of noise is the cellular noise, also known as Worley noise. It returns two values that can be combined in various ways. As you can see, it is very easy to create an interesting looking pattern with the pseudo-random noise functions. I might explore these further in another tutorial. Lastly, when you make an error in your script and it fails to compile, the refresh button will change to a red warning sign. If you click it, the description of the error will be shown, along with the line number where it occurred. Thank you for watching this tutorial, and I hope it helped you getting started with Shadron or convinced you to give it a try.